welcome to today's webinar from MediaTek Labs, which is on creating wearable devices with the new LinkIt 2523 HDK by SAC. So my name is Michael Francis. I look after the marketing for Europe at MediaTek Labs. Today's presenter is Philip Handschin, who's a technical consultant at MediaTek Labs. So I'm now going to hand over to Philip, who's going to take us through the new HDK and how to develop wearable IoT devices.
Thank you, Michael, and welcome everyone to this webinar this morning, afternoon, or evening. So let's get started straight away. So we look at the topics. I will briefly talk about what MediaTek Labs is, what we're doing here. As an organization. Then I look at the LinkIt development platform for RTOS, kind of as overall, and then the crucial bit is kind of like how to get started. So kind of, once you have your board in your hand, kind of how to get the SDK up and running, compile a test project, prepare to flash the board, and then flashing it, and then create your own project. And in the end, I want to give some hints to the documentation, kind of where to look stuff up. And in the end, as Michael already said, we will be open for questions. So let's dive straight in. So what is MediaTek Labs? We are a developer program from MediaTek, and it's a completely free program, and you can join on labs.mediatek.com. And we support various different developers, like when you want to create like your own IoT device, or also app devices, app development. But we also help with services. So we want to help you to get from idea to a prototype to a product. So from idea to prototype, we help with HDKs you can use to kind of evaluate our chips, our technology, and to get up and running with a prototype really quickly. So we have Arduino boards, but we have more professional boards as well, like the MT2523. And we have SDKs for Arduino, but also for C and Eclipse environments. And so this will give you really a good starting point to create your prototype very quickly. But furthermore, we also want to help you to put your prototype into production, because we have a developer relations team who can help you find the right prototyping houses or ODMs to kind of make your product a reality. So please get in touch on labs.mediatek.com if you have any questions in regards to that. Our portfolio so far, like we started off with the LinkIt one, it kind of has a lot of connectivity and is Arduino compatible. Then we moved on to the LinkIt Assist 2502, and we added just Wi-Fi boards with the LinkIt Connect 7681 and LinkIt Smart 7688, which is a complete open source Wi-Fi platform. But like later on now, we added the RTOS platform. So we have the LinkIt 7687 HDK, which we already introduced earlier this year. So this is a Wi-Fi development board with the Wi-Fi SoC, but it uses exactly the same SDK than the LinkIt 2523 HDK. But the 2523 is aimed at wearables, and as you can see in the picture, it already kind of has a screen mounted to the board on top here, and the main features are it's a Cortex M4F processor, and it has dual band Bluetooth, so it has Bluetooth, the standard Bluetooth plus Bluetooth low energy, but it also has a GNSS already integrated on the board. We will get to that a bit later on. So we have a huge community based on all these devices, and like daily projects are added on various different websites. So there's a lot of example codes out there and ideas. So please, just look up our boards and you will find a lot of projects with them. So let's have a look at the development platform for RTOS. So the LinkIt development platform. So this time we started with the MT2523G, and we'll go into detail about the chip a bit later. That's basically the starting point for this board. Then we kind of took FreeRTOS as our operating system. Great thing about FreeRTOS is open source and a lot of community support, but it's also used in commercial products. So it's the mix. It's a good mix of both worlds. And then we created SDKs in the toolchain. So we have a complete GCC compiler, like a standalone toolchain, which you can use on Windows or Linux. But we also have support for QU Microvision or IAR. And last but not least, we partnered with SAC to kind of create this whole evaluation board, this HDK. So you can kind of purchase it online and start developing your prototype. So, as promised, a bit more details about the 2523. So it is a system on chip. So it has the Cortex M4 as an MCU. It has an integrated power management unit. It supports dual mode Bluetooth, so for the standard Bluetooth plus Bluetooth low energy. It also has supports low power GNSS, so we have algorithms that kind of optimize the positioning accuracy, but also the power consumption. So we support GPS and GLONASS at the same time, which results in very accurate positioning data. And we also have a rich interface support, so I2C, SPI, I2S, so you know, whatever you need, like the chip will have it. And so we're aiming this at like specifically wearable devices, it's like smartwatches, glasses, but it can also be used for drones or robots or smart toys. So let's get started with kind of the steps you have to take to kind of get your development environment set up. So first thing is to install the SDK. So you have to download it first. You can do that for free on our labs.mediatek.com website. So once you're there, you go on the DevTools resources to LinkIt for RTOS and SDK introduction. And on that site, you will find the IAR and GCC button. So please press that to start the download. You will be asked to agree to our terms and conditions as well. Just read through them and agree to them, and then you can download. This is quite a big package, so several hundred megabytes. So while this is happening, you can install the MinGW, which is a cross-compiler for Windows. So today I'm focusing on the Windows setup, but as I said, like in our documentation, you can find all the steps as well for a Linux setup. So please go to the MinGW download and download the setup file, and then execute your setup file. So you will be greeted by a lovely welcome screen, and press install, and then choose an install directory. I would recommend to keep it simple and just use your C drive, and press continue. Then you have to select some additional packages you need to install. So please make sure you select MinGW32 base and MySys base. And to make sure it gets installed, you have to go to installation and press apply changes. Then you will be asked again to kind of confirm your action. So please press apply, and the packages will be downloaded and installed. Once you've completed that, please navigate to your installation folder on your drive. In my case, it was MinGW MySys or MinGW, and under there you will find the MySys and then 1.0 folder, and launch the terminal screen by kind of double-clicking mysys.bat, and then you should see a screen like you see below here, and that will just kind of make sure that the installation was successful. So I can just show you. So this is my kind of terminal window. Yeah, so it's all installed. So you can close that again. Hopefully by now the SDK has been downloaded, so you can unzip the whole downloaded SDK file into the MinGW installation path. So please go to MinGW MySys 1.0 home and then your username of the Windows system. So in my case that's MT2523G, and then go to and then unzip it into LinkIt SDK version 4.00 public. So that's basically just unzipping the whole file into that folder. Next thing is we need to install the ARM TCC for the Windows environment. So please head to the link here in the presentation and download the installation file, the zip file. And then again, go to MinGW MySys 1.0 home username, and then into the SDK root you just copied in. There you will find a folder tools, and in there a folder GCC. And there you have to create now a folder called Win for Windows. And just unzip the whole folder into this folder, and rename the folder to GCC ARM non-EABI. So after you do that, you should have a folder structure like this. So we see MinGW at the top, then MySys 1.0, your username, the SDK root, tools, GCC, Windows, and then GCC ARM non-EABI. And in here you have like the contents of the download from the ARM website. So this is it. That means your SDK is installed, and you can now start compiling projects. And our SDK already contains several projects, kind of help you get started. Some are applications which show you kind of how to do a certain thing, and other projects are just kind of demonstrating how the hardware access layer works, so kind of I2C works, or SPI works, or the real-time clock works. So how do we go about to compile a test project? So again, we have to launch our terminal by running mysys.bat in our MinGW folder, as we did before, but now we have the SDK installed, so we will have a bit more functionality. So we change to our SDK directory, and then use build.sh list to see all commands and projects. So best thing is to demonstrate that. Let's just clear the screen. So okay. So in here we have our LinkIt SDK with version 4.0. So we kind of change directory into that directory. And in here now you see we have a build.sh. We can run, and we do build sh and then list, which will list all available projects. This will available build projects. So we'll go through all the folders, all the projects, and we'll list them here. while that is processing, we can go to the presentation. So as I said, we built a list. You see all the projects, and then to compile one of these projects, you basically use build again, then the HDK you want to compile it for. So it's the MT2523 HDK, and then we can select the project. So as an example is the RTC set alarm. I have to up my power of the laptop. There you go. So you see we have the 2523 HDK, and these are all the projects you can, you get all the source code as well, and so you can base your initial project on this, or kind of find details about how to use I2C or I2S or the RTC kind of from these projects. As you see, we have a BLE project, also audio, AES for kind of encryption, sensor projects, so a whole wealth of projects you can use straight away. So let me just demonstrate the compiling. So we do build sh, and then we set like the MT2523 HDK, and as a demo we have the LTC set alarm. We execute that, and then you should see it's starting to compile. Yeah. There you go. It's starting. There we go. It's passing, linking, all good. Very nice. Okay, so it's all passed. Great. So we compiled the project. So where are now my files? They are in the out directory. So that means it is in your SDK root. There's an out directory, and then the HDK you use, so the 2523, and then the project name. So let's have a look. So we're here in the SDK directory. In out, we have MT2523 HDK, and then LTC set alarm. And here are now all the 4 files we need to flash the board. But furthermore, we have log files. So if there was like an error during the compilation, you will find it in here. Now, we want to flash the board, and we have to prepare the board for flashing. Actually, it's more like the computer we have to prepare. So, first of all, we have to unzip the PC tool win zip file, which is on the tools. In that folder, you'll find a flash tool for the 2523. But also, you'll find a driver for the board. So please go to please unzip the folder and go to MT2523 flash tool, and then Microsoft USB COM port driver version 1.10321, and then you will find an install driver executable. So just execute it and install the driver. After that, after you've done of the installation, you then can connect the board with a micro USB cable, and be aware to use the top, the first kind of micro USB connector. So the top one is for the board for the 2523, and the one below is for the MK20, which is a debugging chip. We'll come to that in a minute. So once you connected the board, you should see when the installation of the driver was successful, you should see 2 COM ports in your device manager. So let me just show you. There we go. Well, here we go. We have COM14 and COM13 for like the board. Yeah. Next thing is we have to install the driver for the MK20. As I said, this is the debugging chip, so we will see all the debug output on that chip, and you can, on that connection. So again, please download the driver from the website and install the driver. And then you connect it to the lower micro USB cable, micro USB spot. And if we go now to the device manager, you will see an embed serial port. We will use that later on to kind of see all the debug output from the project that's running on the device. Yeah, you see here again, it's the embed serial port. So this means now if you're that far, you have installed all the drivers correctly on your system, and we can go ahead and start flashing the device and see how the project is running on it. So how do we flash the board? Again, we have to connect the micro USB cable to the top micro USB port. But before that, we kind of need to start the flash tool. So first is to disconnect the board from your computer and then start the flash tool. Once the flash tool is started, we go to download as a feature on the left. Then you select kind of your configuration file. You will find this in your out directory where you just compiled your project. And once you selected your configuration file, you then click Start, and you plug the board into the computer. And again, as I said before, it is on the top micro USB port, the 2523 USB port. And once it's all successful, you will see a message. But I better kind of walk you through the whole process. So, under Tools, you will find the MT2523 Flash tool. So you use Flash tool X6. And on here, you select Download, you press Open, and you go to your out directory, 2523, RTC set alarm, and then you select the Flash download CFG file. This will then include all the necessary binaries that need to be flashed. So the board is now unplugged. I press Start, and now I plug in the board, and then you will see the flash is starting and it's done. So pretty straightforward. Great stuff. So we flash that. Next thing is to run the project and see kind of the debug messages. So again, disconnect the micro USB cable after the flashing, which I just did. Then we reconnect the USB cable to the MK20 port, so that's the lower of the two micro USB ports. Then we open a program such as Hyperterminal or PuTTY. We choose a serial connection. We choose the COM port and speed. So the COM port is the one we find in our device manager, and the speed is like 115,200. So let me just do that. There you go. Yeah. So let me double check the COM port. COM port is 63. So 63, serial connection, and I open. So now the whole program already started. So if I reset the board now, I should see all the debug output from that project. this project doesn't have any debug output, so let us kind of flash it with our own project. So and then check that again. So let's create our own new project. So what we do is we copy an existing project folder and rename it to our project. So let's say we want to kind of create a Bluetooth low energy application. We copy an existing Bluetooth low energy project and rename it. And we then need to make some small changes in the make file. We change the code and we compile the project. So let me walk you through it. So if we go into in our SDK root, we go to projects, we go to 2523, and then to apps. We have like a BLE finding application. So we copy that and we rename the whole folder to find you. We open the project, and in the GCC folder we have the make file. So we open that with our favorite IDE. So you can use Eclipse, you can use Visual Studio. It's up to you. And there are like a few areas we need to change it. So we have the project name. We have to change now to find you. And then we just have to basically find all the references to find me. So here we have the app path as well. We change that to find you, and then there's like one more. There we go, flag. Find you. Okay. That's it. And we save that make file. We close it. And the nice thing now is that in our build list, this project will appear, and we can compile it straight away. And then I will show you again how to flash it, and then we will see some debug output on the MK20 chip. There we go. BLE find you is now on the project, and we can now go straight ahead and compile this project. So again, 2523 HDK, and it's BLE find you. That's starting to compile. There you go. It's building successfully the project. And once it is complete, again, it will create a new folder in the apps directory where we will find all the necessary files to flash it to the board. Okay. Just a tip again, if anything goes wrong during the compilation process, there's a detailed log files. So if you need to debug your compilation process, then please go to the apps directory, and on the project and log folder you will find all the details what happened during the compilation process. Also, kind of for then debugging, kind of in more detail, we have like a software debugger you can install on your Windows platform, but that is described in our Getting Started guide. So let's go back. It's still compiling. Okay. Yeah, this is again like how you will set up the PuTTY configuration to kind of connect to your board. As I said before, you will then kind of connect it to the MK20 USB connection. You select serial connection, the COM port, and then connect. Okay, we're linking now, so any second now and they will be all done. Brilliant. Okay, let's open the Flash tool. So we go back to our SDK root on the tools, 2523, Flash tool, download, we open, and now we have the BLE Find You application. And again, we select the Flash download CFG file, which then imports all the necessary binary files. We make sure that the board is unplugged. We press start. We plug it up into the top micro USB connector, the 2523 USB. The board gets flashed, and we can unplug the board and close our Flash tool. And now we connect the micro USB cable to our MK20 USB port, and we open a new session on our PuTTY, and it is the 63. Okay. And now when we there you see is the log output. So if we reset, we will see the whole start procedure. Yeah. So this is how you create your own project from one of our own example projects. I just wanted to highlight some of our documentation. So all our documents are under the SDK root and then on the doc folder. And a really good one to read is how to set up GCC compiler. So it goes all of our points I just made in this presentation, plus some extra information. Then getting started with the development, kind of the best thing to read is the LinkIt for RTOS Get Started guide. You have a wealth of information in there. Also, top tip is the debugger setup is on the point 2.3.6. So if you want to set up the debugger, and then the complete API reference, like all the whole SDK is described on the LinkIt SDK for 2523 API reference manual. So it's a web-based manual where you can click through all the functions, all the information you need to know. Okay, I hope this gave you a good starting point into your development with the 2523. And I think now Michael will open the floor for some questions.
Thank you very much, Phil. That was very interesting introduction there, and I hope everybody else agrees. As I said at the start, we do welcome all questions. We've had a few typed into the chat already. So if you do have some questions, please do type them into the chat or the Q&A. Either's fine. So the first one from Victor is asking regarding replacing some of their system on chips, the MediaTek chips. So Tom, I've sent you my email address. So if you send me an email, we can put you in touch with the right person on that one, and also your question regarding proper dev kits and chipsets for your applications. So send me an email at michael.francis@mediatek.com, and we can take it from there. So we have another question from Wilfred Lohman, who's asking, is there some development program and also information available for LTE/WCDMA modems, system on chips, etc. So, I'll hand that one to Phil.
Yes, no, like our we don't have any modems on our development kits. I mean, we have one on the LinkIt one, which is a GSM GPRS modem, but we don't have any LTE in our development program at the moment.